In this lesson, we're going to be learning how to parse the response that we're getting back from Open Weather Maps servers. So now that you've seen how closures work, let's convert our completion handler here to an actual Swift closure. Instead of creating session.dataTask with URL and passing in the completion handler as an actual method, I'm going to go ahead and initialize this data task again because I'm going to borrow Xcode's code completion to help me. So I'm going to choose the one where I give it a URL and I end up with a completion handler that triggers once it's done with the task. And the URL is again going to be just the URL that we got from our optional binding. But here in the completion handler, where you see this gray area, which is the code placeholder that is telling us what it's expecting. If you go ahead and select it, so turn it blue and then hit enter, it should format it into a trailing closure automatically for you. So now that we see this familiar closure format, we can go ahead and add in the names of the inputs. So that's going to be called data, that's going to be called response, and that's going to be called error. And now inside this code block, we're going to move in everything that used to live in our handle method, and it's now going to go inside our closure. And we can delete this separate method. And then I'm going to select everything and hit Control I, or whatever your shortcut might be if you go to Editor, Structure, and Reindent. So this is what I see. You might have something different. And now I've reformatted my code to look a lot more Swifty with my anonymous function here. And I've got my trailing closure, which is going to carry out this task once it completes with the data task. So now that we're done with getting hold of the data, we don't really want it as a data string because this is impossible to read, even if I concentrate and really squint my eyes. Instead, we're going to parse this piece of data and turn it into an actual Swift object with properties and methods. So to parse this data, which is currently in a JSON format, and I know it's a JSON response because when I look at the documentation, you can see that the example of an API response in the JSON format looks exactly like what we've got. And JSON formatted data that's being transported across the internet is probably one of the most popular and one of the most widely used formats. And other formats like XML is fast going out of fashion. But what exactly is a JSON? What does it actually stand for? Well, a JSON stands for JavaScript Object Notation. This actually comes from the JavaScript world, the web world, where there's a lot of data being transported across the internet, and they need to make it as efficient, as lightweight, and as small as possible. I want you to imagine that you start out with a wardrobe, and this wardrobe happens to be an object that's created in JavaScript. So this is what a JavaScript object would look like. And they're created kind of almost like our dictionaries. But in this case, the object is called wardrobe. It has a property called doors, which is set to equal to, a property called drawers, and a property called color. When this is being transported across the internet, in order to save space, we're going to get rid of all this formatting, which doesn't really matter while it's in transit anyways. And we're going to turn it into a flat pack wardrobe, like the ones you get from IKEA. The flat pack wardrobe still retains all of the most important parts of the data, namely the syntax, the properties separated by commas, and each object encased in a set of curly braces. But it gets turned into a string rather than an actual object. But once it arrives on the other side, once you've gotten it delivered from IKEA and you've managed to find all the screws, which are impossible to find, and you've built your wardrobe back up again, then you still have a living, breathing, large wardrobe. But during transit, it was turned into a much smaller format so that it can be transported easily. Now, in our case, we don't actually want to unpack the JSON into a JavaScript object. What we want is a Swift object to come out of it. So we would initialize our Swift object with either a struct or a class constructor with properties like doors, drawers, and color. So let's see how we can do this. So I'm going to go ahead and delete my comments just so that it's easier for you to see what's going on. Feel free to keep your comment or any additional things that you have in your code if you wish, but I just want to tidy up the code a little bit so you can see more at a glance. So down here below perform request, I'm going to create another method which is going to be called parse JSON. And this is going to take a single input, which is going to be the weather data. And this is of course going to be the format of data, which is the format that we get back from our data task. So then we should be able to call our parse JSON method here and pass over this unwrapped safe data, which meets the requirements of being a data object. But notice how we're getting an error here telling us that call to method parse JSON inside a closure requires an explicit self. Normally, when we call methods, such as when we called perform request, we didn't actually need to say who was the object that owned this method perform request to call this method. And in fact, the full way of writing this code would have been self, so call the method perform request from this current structure, which is here. Now, the reason why we didn't have to do it is because Swift is actually doing it for us under the hood. And this keeps our code nice and tidy, and we already can see that perform request is right there inside our weather manager, so it is superfluous to add the self in this case. But when we are inside a closure, then it can get confused about where to add the self and where to not add the self and where the method you're calling exists. Because remember, our data task is triggering this method, and when it gets triggered, then everything inside gets executed. So inside the closure, the rule is we must add the word self if we are calling a method from the current class, which we are right here. So that fixes that error, and now we can focus on our parse JSON method. In order to parse our data from a JSON format, we first have to inform our compiler how the data is structured, and we can do that through the use of a structure that we create. So in the model folder again, I'm going to create another file, which is a Swift file, and I'm going to call this the weather data, because inside this file, I'm going to create the structure that the weather data is going to come back in. Notice how if we have our data formatted with JSON Awesome, you can see it as a tree structure. So we're getting back an object that has 13 properties. And the first one is a property called coordinate, which inside is another object that has a longitude and latitude properties. And we also have a property called weather, which inside actually has an array with a single item. So we have to basically break down this structure for the compiler to be able to chew through the data that it's getting in this format. And then we can assign property names and we can turn it into a Swift object. So let's start with something quite simple, something that's just got a key and value pair. So for example, our name here. The property name is called name and the value is Paris. In this case, we could create our structure weather data, and it can have a single property called name. And the name, if we check, is of course a string because it's got the quotation marks around it. So we'll assign it the data type of a string. But this is not quite enough. In addition, we also have to say that our struct conforms to the decodable protocol. And that means that the weather data turns into a type that can decode itself from an external representation, namely the JSON representation. Now that our weather data is decodable and it's got a property called name, we can go back into our parse JSON method and create a decoder. And we're going to create that from the JSON decoder object. So this is an object that can decode JSON, and we're going to just initialize it. Next, we're going to use our decoder and we're going to decode. Now, this takes two inputs. Firstly, the data that you want to decode and a decodable type. So a data type that we're using to decode that conforms to the decodable protocol. Well, we've got one of those right here. Our weather data is a decodable type. So notice how in this case it's expecting a type in here as the input, not an object. So to specify the weather data type rather than just the weather data object, we have to add a .self to reference the type. So if I click on this fix button, it turns my weather data into a data type that I'm passing in. Now, finally, the data that we want to encode is going to be passed in as the last input, and that is going to come from this weather data right here. So that's what I'm going to put there. So now we should have decoded our data, but we're still getting errors because it's telling us that this call to decode can throw, but is not marked with a try, and the error is not handled. What does that mean? Well, if we take a look at this decode method again, you can see that it's marked with this throws keyword, which means that if something goes wrong, it can throw out an error. And so instead of simply just calling it as we would with other methods, what we have to do is we have to mark it with a try keyword. And in addition, we should really wrap it inside a block that's called a do block. So the do block has the thing with the try, and that marks the method which can throw an error. But if it does throw an error, we have a catch block that can catch the error. So we could simply print the error in here. So now our error goes away and Xcode is now happy with the way that we're programming our project. The final thing we have to do is that decode actually has an output. So it's going to create a weather data object. Let's go ahead and capture that in a constant. We'll call it decoded data and we'll set it to the output of this method call. And then this decoded data, because it has the data type of our weather data, which means that it has the property name, well, then we can actually print out decoded data dot name. Now let's go ahead and run our app. And if I go ahead and type in the name of a city, say Belgrade, and hit enter, you can see that the name of the city is being printed, but it's not being printed from my weather view controller. There's no print statements in my text field delegate methods. In fact, the only one that's being triggered is this decoded data.name. So some of you might be thinking, well, you could be cheating. That might still be somehow coming from the text field. Show me a piece of data that comes from the API that we didn't enter into the app ourselves. Okay, so I'm always up for a challenge. So if we take a look at our result that we get back, notice how we're getting the temperature of the location back as well. Let's try and get hold of the temperature. Now, a really handy thing that the JSON Awesome plugin can do is when you select one of these properties by clicking on it, you can click on this green button that comes up and copy the path that it would take to reach this value. So now inside here, instead of decoded data.name, I'm going to delete the name and I'm going to paste what I copied over from JSON Awesome. So it's telling me that in order to get to the temperature, I have to take the entire piece of data, go to the main property, and in the main property, go to the property temp in order to get that temperature. And that is what the entire path would look like. But right now, we haven't defined these properties in our weather data. So let's go ahead and do that to make these errors go away. Firstly, we've got the top level, which comes from our weather data, and the top level property name is called main. So that's going to be what we'll add in here, main. But what data type is it going to have? Well, it's actually an object with 5 items, and that object has these properties: temp, pressure, humidity, etc. That means we actually need another struct, which I'm just going to call main. And this again has to be decodable. And then this main is the one that's going to have that property temp. And remember that when you're creating these properties, it's a little bit different from how we would do it normally when it's entirely our code. We can't just name these property names whatever we want. For example, if I called this temperature, then this decoding process is not going to work. So I have to make sure that my property names match the names of the properties that I'm seeing in my JSON data precisely. So this temp that I get back is a number with decimal places. So let's make that a double data type. And now that we've created this main struct, we can use it here as the data type of the main property. So let's add that right there. Now this error goes away, but the error inside the weather manager also goes away because our decoded data, which is of data type weather data, now has a property called main, which holds a main data type, which has a property of temp. So 3 steps to get to the temperature, but if we go ahead and run our app, and I type in, let's see what the weather's like in Paris again. Let's hit enter. You can see that I'm getting the temperature printed now from our decoded data.main.temp. And in Paris, it's a lot nicer than in London, as usual. So now for the final thing that we want. What if we wanted to get hold of this description right here? How would you go about getting it using our JSON decoder? So this is going to be set as a challenge for you. Take a look at the data in Chrome using the URL and using the JSON Awesome tool to get the path of this particular description. Remember that this weather property holds data inside an array. And that's my hint to you for making this work. Try and get this description printed when we request for the data in our text field for a particular city name, and pause the video and try and give it a go now. All right, so the first thing I'm going to do is I'm going to copy the path, and again, I'm going to replace my main.temp with whatever I copied over. So in this case, it's going to be from our decoded data. I'm going to go straight to the weather property, and then within the weather property, where I've got an array with a single item, well, I'm going to get the first item in that array. So now inside this array's first item, I've got an object that has a property name of description. So then description goes in at the end, and that's how I'm going to get hold of that description. So now all we have to do is to map that structure in our weather data file. The first thing we have is a property at the top level called weather. So I'm going to create a property called weather that matches that exactly. Next, I'm going to create my weather property, which is going to be a weather data type. And just like the main data type, we have to create a new object But this time, instead of simply just having a weather struct as the value of the weather property, it's actually an array of weather items, right? So the weather property holds an array. How can I represent that? Well, I can go ahead and simply wrap this inside a set of square brackets. Now I can create my weather structure, which has a property called description. And so here, let's create our description property, which is going to be a string, and make sure that our weather struct is again decodable for our JSON decoder. Now, if we go ahead and run our code, then the errors go away. And let's check the weather for Beijing. And you can see that in Beijing, there is clear skies all around. And we're getting that through decoding our JSON data using the JSON decoder from Swift. And we formatted the data using these decodable structs. And finally, we're printing it out. If it's still confusing, I recommend just taking a look at your JSON, trying to get hold of different values from this JSON, and having a practice by adding more structs and properties. But in the next lesson, we're going to use our decoded data and format the data so that we can put it into our UI. For all of that and more, I'll see you on the next lesson.